Number 20, the distress flare shot up 80 degrees from a ship's bridge, 102 feet above the water, with an initial velocity of 156 feet per second. Part A asks, what is the maximum height of the flare to the nearest foot, and how long has the flare been above sea level to the nearest tenth of a second is part B. So let's first draw a quick picture here. We have some ship out at sea. And the ship has some bridge and it has a gun that shoots off. Someone up there shoots off a flare well above seawater. So obviously this is not the scale. They shoot off a distress flare. And the flare is going to go up, and then it's going to come down. And ultimately, it's going to go down until it hits the water here. So now, part A is going to ask for, what is this maximum height? That's what part A is. And part B is going to say how long. Part B is how long until it hits the water. So let's figure out, given the information we have. First, this flare shot up 80 degrees. So if you went straight out from the shot, or straight horizontal and then curved up, that's 80 degrees there. And it was shot at an initial velocity of 102 feet above water. So this is 102 feet, this distance here. And the initial velocity coming off would be like this vector here, because when you shoot, you don't actually shoot a curve. You would shoot something like this, a straight line that gravity pulls down. It comes off at 156 feet per second. So that's our value there. Now, we're going to use the same formula we've been using to solve for this. It says here, we're going to go to projectile motion and use these two formulas. So we have that x equals the initial velocity times cosine theta times time. Y is going to equal negative 1/2 gravity times squared plus initial velocity times sine of theta times time plus the initial height. Well, let's look in this problem. What do we know? First, we know our initial velocity is 156. So that goes in these two places. We have 156. Secondly, we know the angle. We shoot at 80 degrees. So that goes there and there. Next, we know initial height. Initial height is 102. That goes there. Finally, we got to figure out gravity. Since everything is in feet, I'm going to use this g that has to do with feet, which is 32. So here, I'm going to replace g with 32. Now we're going to go to our calculators and graph this. So I'm going to clear this first. And I'll go menu, graph entry. I'm going to go to parametrics. And I'll type in my equations. The first one was 156 cosine of 80 degrees. I'll click the degree button down here with pi. And I'll put the t out here. And now gravity was negative 1/2. And then instead of g, we are going to replace it with 32. And that's time squared. And then we add the 156 sine of 80. I'll put the degree symbol again, time, and then I'm going to add the initial height of 102. And after hit enter, I see nothing because of how high this is shot off at. So I'm going to do menu, window, zoom fit. And I can see that this is up in the air way too long. It still hasn't gotten to the ground yet. So I want to pull up my equation again and change my time. Instead of stopping at 6.28, let's try going to 12 seconds. I'll press enter. I'm going to go back to menu, window, zoom fit. And now here's my picture. I can now see it. So we first want to determine the maximum. So I can go menu, trace, graph trace. And I'm going to go to the maximum value. And now the maximum is going to be determined by this y. So I'm going to look for when it's the highest. It looks like 471 is the highest, but we can probably zoom in to see if it gets any higher. The way to do that is I'm going to analyze graph, and I'm going, trace, and I'm going to change my trace step. Instead of counting by 1/10 of a second, I'm going to change it to like 100th of a second. We could do 1,000th, but I'll go a little bit quicker, because we'll probably be able to determine where that maximum height is. So as I go this way, I'm watching 100. It looks like 471 is the highest value. I'm going back and forth, and I don't see it getting any higher than 471. So 471 is going to be my highest point. That's part A. So the nearest foot is 471 feet. So 471. 471. Now, how long is a flare above sea level to the nearest tenth of a second? So I continue on, but I need to first change this back. I want to count quicker, so I want to change my trace step back to the automatic, which is 0.1, or you can just click the arrow and choose automatic. Now it'll go faster. I want to know to the nearest tenth of a second, how long is it above the water? So now I'm looking for the y to be above 0. So I'm going to keep going on until I get to here. I want to be above the water. So right now I'm at 4.39. I hit this, I'm at negative 13.1. So it's either 10.2 or 10.3 seconds, somewhere in here. Again, I'm going to count by tenths, just because I'm going to see which way will it round. So I'll do, set a point. I'm sorry, I said tenths, I mean hundredths. Now we'll see which way it rounds up. So I'm going to count on, I'm going to go, and I'm going to go. Okay, so now I'm at negative. That means the flare's under water at 10.2. And I'm above water here at 10.2. So it's at 10.2 seconds that it hits. So that answer to B would be 10.2. 10.2. Those would be my answers here.